What if the most important discovery in human history is not waiting on a distant planet, but passing through our solar system right now? Imagine that an interstellar object moving through the darkness between stars is not just made of ice, dust, and rock, but is carrying something alive, not a machine, not a coded signal, actual organisms, tiny life forms that may have been placed there billions of years ago by an intelligence far beyond our own. That idea sounds extreme at first, but stay with me, because what makes this story so powerful is that it does not begin with fantasy. It begins with real scientific questions, real telescope data, and a mystery that has forced serious astrophysicists to think far beyond the usual explanations. For decades, scientists have debated one of the deepest questions in all of science. Did life begin here on Earth, or did it come from somewhere else? That question alone is already profound. But what researchers are now asking about 3I, Atlas, pushes the conversation even further. Could this interstellar visitor be more than a natural object? Could it be something like a cosmic garden, a vessel capable of spreading life from one world to another? And if that possibility is even remotely real, then the next question becomes impossible to ignore. Who planted the seeds, and why? To understand why this idea is being taken seriously at all, we need to go back to the beginning, not the beginning of 3I, Atlas, but the beginning of life itself. Because the truth is, your own origin may be stranger than most people realize. There is a real scientific argument that life on Earth may not have started here. It may have started on Mars. That is not a joke, and it is not a movie plot. It is based on a simple but compelling line of reasoning. Mars is smaller than Earth, which means it cooled faster. More than 4 billion years ago, when Earth may still have been too violent and too hot to support biology, Mars could already have had liquid water, stable conditions, and the chemistry needed for life to emerge. Then came the impacts. Asteroids slammed into the Martian surface and blasted rock into space. Some of those rocks traveled across the solar system and eventually landed on Earth. We know this happened because scientists have found Martian meteorites here on our planet. One of the most famous is ALH 84001. When researchers examined it, they found that during its journey from Mars to Earth, it was never heated beyond about 40 degrees Celsius, roughly the temperature of the human body. That matters because it means microbes, if they had been inside, could have survived the trip. Now pause on that for a moment. We have direct physical evidence that rocks can move between planets without becoming hot enough to sterilize whatever might be inside them. That alone changes the conversation. It means the transfer of life through space is not just a wild idea. It is physically possible. And when scientists traced the genomes of hundreds of modern microbes back toward the last universal common ancestor, they found evidence suggesting that this earliest common life form existed around 4.2 billion years ago. That is very early, only a relatively short time after Earth formed. In fact, it may be too early for life to have started from scratch here without help. The timing lines up surprisingly well with the period when Martian material could have been arriving on Earth. Scientists call this process panspermia, the idea that life can spread naturally through space on rocks and debris. It may sound like science fiction, but the physics behind it is real. Life, especially microbial life, is tougher than we once believed. Some microbes can survive vacuum, intense radiation, and long periods of dormancy. They can shut down, endure extreme environments, and potentially remain viable for astonishing lengths of time. But that leads to a bigger and much more unsettling thought. Natural panspermia is possible, yes, but it is also wildly inefficient. Most of the material blasted off a planet never reaches another world. Even when it does, it often burns up or lands in ways that destroy anything living inside. So, if nature can barely do this by chance, what would happen if an intelligent civilization decided to do it on purpose? That question is where this story changes completely, because once you accept that life might survive interplanetary transfer by accident, you also have to confront a much more deliberate possibility. What if a civilization somewhere in the galaxy decided not to leave the spread of life to random impacts and blind luck? What if it chose to engineer the process? What if it built cosmic delivery systems, vessels designed to carry biology across the stars and release it onto suitable worlds? This concept has a name, directed panspermia, and it is not some fringe internet theory. It was seriously discussed by Francis Crick, one of the scientists who helped discover the structure of DNA. He raised the possibility that life on Earth may have been intentionally seeded by an advanced extraterrestrial civilization. For a long time, most scientists pushed that idea aside because it felt too speculative and impossible to test. But 3I Atlas may have changed that. For the first time, we are watching an interstellar object pass through our own solar system, while modern observatories are fully capable of analyzing it in extraordinary detail. That is why so many researchers are paying close attention. When the James Webb Space Telescope turned toward 3I Atlas, scientists expected to find the usual chemistry associated with an interstellar comet: water, ice, carbon dioxide, maybe carbon monoxide, the familiar ingredients of a frozen object that has spent immense stretches of time drifting between stars. But what they found was more complicated than expected and much harder to explain cleanly. The gas and dust plume around 3I Atlas contains water, carbon dioxide, carbon monoxide, and methane. None of that is automatically proof of life. These molecules are found in many environments across the universe. They can form naturally in molecular clouds and become part of comets and asteroids during the birth of planetary systems. But what has drawn such intense attention is not just the presence of these molecules, it is the pattern in which they appeared. Data from the Spherex Observatory indicated that organic material was being released from 3I Atlas at a notable rate relative to its water output. That alone made scientists look harder. Then came the methane anomaly, which is one of the most puzzling details in the entire story. Methane was only clearly detected after the object passed closest to the Sunday. Before perihelion, when it was still approaching the Sun, there was no methane signal. None. That is odd, because methane ice is highly volatile. It should begin sublimating, turning from solid into gas, at lower temperatures than many other compounds. In simple terms, if methane were sitting near the surface, astronomers should have seen it much earlier. Instead, they did not. The pattern suggests that the methane may have been buried deeper inside the object, shielded from solar heating until enough warmth penetrated inward. Only then did it begin to escape. But that explanation creates another problem. Carbon monoxide, which is even more volatile than methane, was detected before perihelion. So why would carbon monoxide appear earlier while methane stayed hidden? The expected chemistry does not line up neatly. The thermal behavior does not behave like a simple natural model would predict. Something about the object seems inconsistent with the standard picture. And that is the point where one of the most provocative questions in modern astrophysics enters the conversation. Could the methane be biological in origin? On Earth, methane is deeply tied to life. Microbes known as methanogens produce it. Animals contribute to it through digestion. Decomposing organic matter releases it. Here, methane can come from geology, but it is also one of the strongest biosignatures linked to living processes. So, some researchers began asking whether the delayed methane release from 3I Atlas might not be a geological mystery at all? What if it is the result of dormant organisms becoming active when heat from the sun finally reached the interior? That idea sounds extraordinary, and it is. It is not proof. No serious scientist would claim that life has been confirmed on 3I Atlas. What we have is an anomaly, and anomalies are where science becomes most interesting. They force us to test assumptions, question models, and consider possibilities that once felt too strange to say out loud. But there is an even more mind-bending implication. If the object is not just naturally carrying life, then perhaps it was meant to carry life. And once you start thinking in those terms, 3I Atlas stops looking like a random traveler and starts looking like something far more purposeful. Now take that idea one step further and picture the universe through the eyes of a civilization far older and more advanced than ours. Imagine that such a civilization has explored nearby star systems and found worlds with oceans, stable temperatures, and the right chemistry for life, but no life has emerged there yet. What would it do? Would it simply observe those empty worlds and move on? Or would it choose to intervene in the quietest and most profound way possible? Would it plant seeds? Human beings have always tried to outlast themselves. We have children, we build monuments, we write books, and we create art because we want some part of us to remain after we are gone. But an advanced civilization might think on a different scale entirely. Its greatest legacy might not be a structure on one planet. It might be life itself, spread from system to system, creating ecosystems and perhaps even future civilizations that grow from the biological seeds it left behind. This is not only a philosophical idea. Some scientists have proposed a practical method that uses interstellar objects exactly like 3I Atlas. The logic is surprisingly direct. A civilization detects a fast-moving interstellar comet entering its planetary system. It calculates the object's path and launches an interceptor spacecraft. That spacecraft carries a payload containing microorganisms, spores, seeds, or genetic material. Whatever forms of life are most likely to survive the journey ahead. It then deposits that payload on or inside the object. The payload also carries radioactive material, not as a weapon, but as a heat source. The slow decay of that material provides warmth, allowing the biological material inside to remain viable, perhaps even metabolically active, over vast stretches of time. Then the object continues on its way. For millions or even billions of years, it drifts through interstellar space. The organisms inside endure, adapt, and remain protected within the natural shielding of the comet or asteroid. Eventually, the object enters another planetary system and moves close to a new star. Its outer layers warm up. Ice begins to sublimate. Gas and dust are released, and with them, the biological material inside. Those particles spread outward like seeds on a cosmic wind. Most are lost. Some are destroyed, but a few may reach habitable worlds. If conditions are right, life begins. Evolution takes over. In time, entire biospheres may emerge from a mission launched so long ago that its creators no longer exist. What makes this concept so unsettling is that, in principle, humanity could attempt something like this with current technology. 3I Atlas passed through our solar system while we had the ability to detect it, track it, and at least consider interception. Had a mission been prepared immediately after discovery, an interceptor might have reached it near its closest approach. A capsule carrying terrestrial microbes and a controlled heat source could, in theory, have been delivered onto the object. From there, Earth life might have begun a journey to other star systems at a speed far greater than anything humanity has ever sent beyond the Sunday. The cost of such a mission, according to some estimates, would not be beyond imagination. For the price of a single large megaproject on Earth, humanity could create what may be the longest-lived monument in its history. Every building, every city, every artifact we have made will eventually vanish. Our sun itself has a finite lifetime, but life sent outward on interstellar carriers could persist far beyond the death of Earth, far beyond the destruction of the inner planets, perhaps for trillions of years, as it spreads and evolves in places we will never see. And that thought leads to the question that changes everything. If we can imagine doing this now, if we are already capable of designing such missions in theory, then how many other civilizations may have done it before us? The universe is ancient. Our solar system is comparatively young. Countless civilizations could have risen and disappeared before Earth even formed. They may have had billions of years to scatter life-bearing vessels throughout the galaxy. If that happened, then perhaps life on Earth did not begin here at all. Perhaps the first microbes that led to every plant, every animal, and every human being arrived on a mission launched by beings whose names we will never know. And if 3I Atlas gives us even a small chance to test that possibility, then this is not just a passing object. It is a direct challenge to everything we think we know about our place in the universe. If you want Part 4, Part 5, and Part 6 inches, the same seamless style, send me the next message, and I'll continue exactly from this point. Right now, as you're hearing this, telescopes across the world are locked onto 3I Atlas. From powerful ground-based observatories to orbiting instruments like the James Webb Space Telescope, scientists are watching every movement of this interstellar traveler. Every photon of light reflected from its surface is being analyzed. Every gas released from its icy body is being measured. And researchers everywhere are searching for one thing that could change science forever: evidence of life. The first step is studying molecular signatures. We already know that 3I Atlas is releasing water vapor, carbon dioxide, carbon monoxide, methane, and organic compounds. But life leaves more complex chemical fingerprints. Molecules like amino acids, proteins, and advanced organic structures have very specific spectral patterns. Webb's instruments are sensitive enough to detect some of these patterns from great distances. At the same time, the Spherex Observatory is scanning infrared wavelengths, searching for subtle clues that could indicate biological chemistry rather than simple geology. Another method scientists are considering involves isotope ratios. Living organisms on Earth tend to prefer certain isotopes of elements like carbon and nitrogen. Because of this, biological processes leave a recognizable chemical imbalance. If scientists could measure those ratios directly in the material coming from 3I Atlas, they might be able to distinguish between purely chemical reactions and processes connected to life. Unfortunately, without a spacecraft to collect samples, that test remains out of reach for now. The third method may be the most fascinating. Scientists are watching how gas production changes over time. If methane is being produced by living microbes rather than by geology, its release might increase when the object warms and decrease as it cools. These patterns could hint at metabolic activity. So far, the data remains uncertain, but the possibility alone has electrified the scientific community. Because if even one clear biosignature appears, the implications would shake humanity's understanding of life itself. Imagine the moment when scientists finally confirm it. An official announcement spreads across the world. An object from another star system contains living organisms, not fossils, not chemical traces, but actual biology. It would instantly become the most important discovery in human history. For thousands of years, humanity has asked whether we are alone. The answer would suddenly shift from speculation to reality. Such a discovery would change far more than astronomy. It would transform biology, evolution, and our understanding of life's origins. If microbes can survive interstellar journeys, then life may not be confined to single planets. It may travel between stars, spreading slowly across the galaxy over unimaginable periods of time. Worlds with suitable conditions might eventually receive these microscopic pioneers, allowing life to take root again and again. Even more astonishing is the possibility that life across different planets could be connected. The organisms drifting on interstellar objects might share ancient ancestors with life on Earth. If that were true, it would mean the tree of life does not begin on one world. Instead, it could extend across the Milky Way itself, linking distant biospheres through shared origins billions of years in the past. But there is also another possibility. The life forms, if they exist, may be completely different from anything we know. Different chemistry, different genetic systems, different ways of surviving. Discovering such organisms would reveal that life can arise in multiple ways, making the universe far more biologically diverse than we ever imagined. Either outcome would reshape science forever, because the moment we find life beyond Earth, the universe stops being silent, it becomes a living place. And humanity's role within it suddenly becomes far larger than we ever believed. Yet there is one frustrating reality about 3I Atlas. When astronomers first detected it in July of 2025, they immediately calculated whether a spacecraft could intercept it. Surprisingly, the answer was yes. If a mission had been launched within weeks, a fast probe could have reached the object near its closest approach to Earth. That spacecraft might have taken samples, analyzed its chemistry directly, and perhaps even answered the question of life beyond our solar system, but no mission launched. The discovery came too suddenly. Space agencies did not have an interceptor ready. By the time the scientific community fully realized how important this visitor might be, the opportunity had already begun to slip away. Now 3I Atlas is racing back toward interstellar space at nearly 60 kilometers per second. Every day it grows more distant, and eventually it will disappear beyond the reach of our telescopes. Yet this is not the end of the story. Astronomers now know that interstellar objects pass through our solar system more often than we once believed. Before 3I Atlas, there was Oumuamua in 2017 and Borisov in 2019. New sky surveys, like the Vera Rubin Observatory, will soon detect many more. That means future opportunities will come again. Scientists are already proposing rapid response missions, spacecraft designed to launch quickly whenever a new interstellar visitor appears. Next time, we may be ready. Next time, we might intercept the object, analyze its material, and finally learn whether life travels between the stars. And perhaps one day, humanity will take an even bolder step. We may send our own biological seeds outward, using interstellar travelers as carriers for Earth life. If that happens, our legacy will not be monuments or cities. It will be living ecosystems scattered across the galaxy. If you're fascinated by mysteries like this and want to explore more cosmic discoveries that could redefine humanity's place in the universe, make sure to like the video, subscribe to the channel, and join us for the next journey into the unknown.